Hi. In the last video, we got to the point where we were able to execute code in the emulator. That's a pretty big milestone. Now, not every instruction is implemented, but I've got enough going that I can actually consider it executing code, not just loading values into a fetch register. That sets me up for what I want to do today, and that is to start working on the PCBs for the Control ROM control and the control ROMs themselves. Now, I've got 16 of these little ones to solder up, one of these not quite so little or more medium-sized ones, and then I've got an entire backplane still sitting behind me that still needs to be tackled as well. I may not get through all of that in this video. With that, let me break out the soldering iron and we'll get right into this.
Hi, I'm Adam. I'm still building a 16-bit computer from scratch. I'm no expert here. I make lots of mistakes. So many mistakes I've actually had to reboot my computer build. I hope you will find my journey interesting, and I hope you will join me as I learn along the way.
My wife Carrie has been working on a cookbook. Carrie's cookbook provides a unique culinary experience by seamlessly incorporating doTERRA essential oils into a diverse array of mouth-watering recipes, transforming ordinary meals into extraordinary dining adventures. The cookbook offers a treasure trove of innovative dishes that combine the health benefits and aromatic richness of essential oils with fresh, wholesome ingredients, making gourmet cooking accessible and exciting for everyone from novice home cooks to seasoned chefs. Each thoughtfully crafted recipe not only tantalizes the taste buds, but also promotes an overall well-being, harnessing the natural potency of pure essential oils such as lavender, lemon, peppermint, and basil. In Carrie's cookbook, she emphasizes the quality, flavor, and simplicity, guiding you through detailed, easy-to-follow instructions with beautiful photography and expert tips. Whether you're looking to elevate your everyday meals, explore new flavor horizons, or embrace a healthier lifestyle, Carrie's cookbook is your ultimate guide to enriching your kitchen and your life with the magic of doTERRA essential oils. If you are interested, there's a link in the description. I've been having a little bit of trouble with the audio, and I had to reset up my overhead on my laptop, not exactly sure why. So hopefully this works out well, and if not, please bear with me as I try to work through some of the technical issues. One of the things I realized in the last video was that the LEDs here were not going to provide any value at all in this particular module. So my plan is not to populate these. This is the top side of this PCB. Now on the back side of the PCB are the resistors that current limit those LEDs, and then the 74HC541s which drive the LEDs. Finally, you've got the capacitors here that are associated with those ICs. Again, none of this is going to be populated at this point. Again, it's not a fatal flaw. All it is just removal of components which bring no value, and ultimately I'm going to want to respin this, but because it's not a fatal flaw, I'm just not going to populate these. Other than that, as you can tell over here, it's actually a very dense board. There's a lot going on this, and I am not totally convinced I'm going to be able to get my soldering iron in here to do all of this soldering. I've got room here for either a half can or a full can oscillator, or on the back I've got some 0 ohm resistors where I can actually take the system clock off the actual clock module and drive it that way. I'm going to start with the actual clock modules, and then I may come back and later populate this crystal if I think I can get better speeds out of it. Finally, I've got a number of unused gates, and many of these have 0 ohm resistors to ground just to make sure that they're not floating. This is CMOS logic, so you do have to do something with those one way or the other. And then the outputs themselves are available, but I won't be tying those with 0 ohm resistors because they really go no place. The other thing I've done, and I'll zoom back out just a little bit here, is I've put this piece of paper together that has all the different components taped down that I'm going to need for this. So all of these are going to be placed on here, and I've got them identified so that I can find those, I hope. This is a two-sided PCB, and so I'm going to have to start, I believe, with the back side, load that, switch over to the front side, load that. First order of business is to get the microscope out and the PCB holder so that I can start putting components here. Okay, I think I've got everything I need to get started here. I'm just going to place that holder on the microscope, pull the microscope closer to me. And the problem with the microscope is it's monocular, meaning I don't get any kind of depth of field. I'll get started on this. I'm going to start with these, point with my flux pen. I'm going to start with these capacitors. I've got some down here, but I'm likely to have to switch and move this PCB around a little bit as I continue to work on this. We'll see how this goes. Alright, so my first problem is that I don't have the ability to turn this around easily, and therefore I don't have the ability to solder the other side easily. Is that a problem? Not in and of itself. Well, maybe it is a problem in and of itself. Well, that's two, and I would not quite call that fun. The other piece of this is I'm very much out of practice. And one of these two sides has a pretty significant ground plane, and that's the side I'm soldering now. Okay, I'm having some trouble with my microscope, but I'm basically going to put my head down here and work my way through this. Okay, at this point I've got a 74HC 193 soldered in. This is one of the counter ICs. And I'm currently working on a 74HC 157. This is a quad 2-to-1 demultiplexer. There are two of these 74HC 157 quad 2-to-1 demultiplexers on the back of this PCB. I'm working on the second one. And I get a little over ambitious with the solder, so I've got a little bit to clean up here. Next up is another 74HC 193 counter IC. The reason this takes so long, even though it looks like it's soldered down, is I want to make sure that the pads themselves have a reasonable amount of solder on them just to make sure that they're holding the pins down. What I don't want to do is go back and have to troubleshoot in. Next up are some capacitors and 0 ohm resistors, which are unfortunately off screen. It's about this point I realized that I can actually turn the microscope without actually disturbing the picture, and I do that in order to get a little bit better angle on what it is that I'm soldering. I'm able to get through the rest of the capacitors somewhat easily. I won't say easy. Then I place the 74HC 165. This is the parallel in, serial out shift register. Now some 0 ohm resistors for an unused gate. Now this is for the inputs to make sure that they are pulled low. If I end up needing that gate, it also gives me a place I can bodge in a connection to the gate that I want to use. And while I was talking, I moved on to the 74HC04. This is a 6-gate inverter IC. Now for a 74HC08, this is a quad AND gate, dual input. And then a 74HC03, this is a quad NAND gate, but this is open drain. And finally, some more 0 ohm resistors. These are for another unused gate to pull the inputs low. Okay, this is the bottom side fully populated. I'm going to clean this up and then I'll flip it over and work on the top. Okay, now for the top side of the board. The first thing I want to work on is the capacitors. Now these are related to the 4 ICs, the 74HC193 and 74HC157 ICs. I decided to work my way down the board, not do all the low components first and then kind of work my way up. Next is one of the counter ICs and one of the demultiplexers. These are located at the topmost edge of the board for me. So the technique I'm employing here is I have flux on one side of the IC. I put a little bit of solder on the tip of the soldering iron and touch one pin, make sure that it's still lined up, and then touch another pin just to make sure that it's held in place in two places. And then I'm coming along and touching the solder to the tip of the iron and using that then to connect each of the pins on the one side down. I add flux to the other side and then wrap up the other side after that. I'm not dragging my way across the pins per se. I do dwell a little bit just to make sure that everything gets heated up properly. Okay, now having flipped the board around, this is the 74HC08 and its capacitor. The 08 is a quad dual input AND gate. There's a second 74HC08 IC right below that, so I work on its capacitor and that IC. Next are some 0 ohm resistors for some unused gates. These unused gates are related to the open drain NAND gate, the 74HC03. And while they're not used, I do have to do something to pull them down, and I wanted them available just in case I decided to bodge my way into those later. Now there's a column of ICs just to the right of those 0 ohm resistors, and I start placing the capacitors for those. Maybe not the best order because the capacitors kind of block my ability to access the ICs later. Okay, this is the last 74HC193 IC. This one in particular is used to count the number of bits that have been shifted on the shift register. Following that is a 74HC32. This is a quad 2-input OR gate. And finally in that column of ICs is 74HC00. This is a quad 2-input NAND gate. Okay, reorienting the board so that I can more easily access the pins here. The last 74HC00. The last IC to place is a 74HC74 2D type latches. Finally here I've got 4 more 0 ohm resistors. These are again pulling down unused gates on the AND ICs. The placement here was very dense and I actually had trouble getting the soldering iron in to complete this soldering job. Okay, and here's the completed PCB. Now, well, I use completed, I guess, in air quotes. I have not soldered in the pins yet. I'm going to be using those thin turned pin for these because I don't expect to be adding and removing this PCB frequently. So I will end up doing those last right before I actually insert it into the board, just as a protective measure. While it's very dense, I'm actually quite pleased with this. It would have been easier to use heat, like a heat gun and solder paste, but I never got the actual template for these. Besides, soldering like this is at this point in my soldering career, a perishable skill. So I'll take the practice. Okay, next step is going to be the Control ROM module itself. Now, I really liked what I did with the Control ROM control here, in that each of my reference markings for each IC is actually stuck right above pin 1. I didn't do that on this one, and so I'm going to have to be very, very careful about how I place each of these ICs. I also placed 2 47 microfarad capacitors on the PCB, but I think I'm only going to populate 1. I'm more concerned with the initial amperage draw to charge all of these capacitors than I am about the bulk decoupling capacitance on the actual PCB. I've done the same thing here that I did the last time, and I laid everything out on a piece of paper so that it's a little bit more organized, and of course I've got it all taped down just to keep it from running away from me. Worked out well. I think I'm going to continue to do that. So once again, I need to get the microscope out. I'm going to start on the back side of this and start populating things, except for the pins, and the cradle for the EEPROM will be the last thing in. I'll see you back after with a microscope. All right, first up on the back is going to be the resistors here. So all in, this first board takes about an hour to solder up. By the time I get to the 16th board, I have that time down to about 20 to 25 minutes. I also skip using the digital microscope for the rest of the boards. That allows me to go a little bit faster because I'm not chasing not being able to see or a monocular microscope. Next, I do the capacitors. Now, this ends up being a mistake because it makes it very difficult for me to get in and solder in both of the ICs because the capacitor is actually in the way. One of the two 74HC541 line drivers. And the 74HC574 octal D-type latch. And finally, the last capacitor on the back. On the front of the PCB, I'm going to start with the remaining decoupling capacitors for the ICs. Next is the 74HC164 IC. This is a serial 2-parallel shift register. And then the second 74HC541 line driver. Now after this, I take to actually holding some of the larger ICs in place with my finger as I'm tacking it down. It turns out I feel like I've got a little bit better control with that. I don't necessarily recommend it, especially if you're jumpy with the soldering iron in your hand. For me, it ended up actually dramatically speeding up this process of building out 16 PCBs. Now the LEDs turn out to be every bit as fussy as the resistors were. The LEDs, though, are very much unidirectional. I have to get the orientation correct. The last thing to solder in place is the cradle for the EEPROM, and then fitting the EEPROM in each one of these boards. Okay, and here are all 16 of the Control ROM modules completed. Now, yes, I did actually take an old tackle box and pull the plastic bins out of it and repurpose them. I figured it would be a good use for that type of container. So here we go. I need to test these. I don't have pins in these yet because I figured I was going to be able to test these individually before I wired them up for dropping into the control logic midplane. And I figured it would be good to test these before they got dropped in here. The problem is being able to test. I need all kinds of different connections all over the place in order to be able to do that. And so I would be soldering in temporary connections, removing them, potentially destroying the pins, and then resoldering in new pins or whatever it was that I actually did here. The better choice, in my opinion, is going to be to solder in the pins and the sockets into the midplane, pins into the individual boards, and then hook up each of my connection points that I need for testing. And then as I continually build this out, one PCB at a time, then I can test it and make sure things are going to work. I want to start with Control ROM control. So these slide off to the side for now. What do I need to do for this in order to get this to work? Well, my program ROM copy address output is going to allow me to monitor and make sure that the Control ROM control is counting through all the different addresses and actually performing some sequence here. My address register input over here is going to allow me to feed in addresses for the Control ROM module to pass off to all the Control ROMs for lookup. So that's going to be needed. And then over here I've got control signals that are coming in that I'm going to want to populate as well. Things like clock and reset and the like, so that I can trigger things being copied. I'm going to start by soldering up the pins and the sockets and then my connection points here so that I can prepare to do some testing. And then I'm long enough into this video that as soon as I get this resolved and working, I'm likely to wrap this up and come back and work on the rest of the mid-plane for the next video. Alright, let me prepare to start soldering here. Okay, so I'm just about ready to start soldering. Besides all the connections I need for the Control ROM control module itself, I'm going to be soldering up a socket block for the control signals, a socket block for the Control ROM copy address, a socket block for the instruction input, and then I'm going to solder up some pins here just so I have a place I can connect power. Or I could do that over here. Let me do that over here. So I will pick a VCC pin and a ground pin that are separate from each other, and then I will add a capacitor here just so that I have some decoupling here on this particular PCB. Soldering iron's warming up. Let me get into that. Now this pin in particular does not need to be straight, because I'm only ever going to be hooking up a alligator clip to it, but I'll try to get it as straight as I can. Yeah, not horrible. Not fantastic, but not horrible. Now these pins here are alternating VCC and ground. So I should be able to come all the way down here to the bottom pin and solder that as well. So this is set now in such a way I can hook up VCC and ground. Let me get a decoupling capacitor in there. Now this is one of those situations I am not certain I have enough room to actually complete the soldering I have intended. So we'll see how this actually works out, and I'm referring specifically to the capacitors. I don't know that I won't be able to solder this capacitor in just simply because it sits so close to this capacitor. That's a design mistake. Alright, next up is, let me get the control signal soldered in. And once again, I'm going to solder one pin and then make an effort to get this straight. As you can see, it's nowhere close at the moment. Okay, now to spend a minute to solder up all these pins. Okay, next is to get all these pins and sockets that I need for the PCB. Get those trimmed down to size and fitted and oriented correctly, and inserted into the PCB and the midplane so that I can actually get them all soldered. To say that this is a fussy bit is actually a huge understatement. At this point, I'm going to tack one pin from each of these groups of pins and sockets so that I can flip the entire board over, and then tack the other side in the same manner. Even when you're doing through-hole soldering, the flux helps. And finally, it's just a matter of finishing up the pins on the Control ROM control module. Okay, let me go clean this up and we'll figure out what we need to do to test it. Now for testing, I'm definitely going to need my clock module. On there I have a high-speed system clock identified that's going to be connected up to this control block here. I've got the actual CPU clock identified. That also is going to be hooked up here. I've got my reset figured out over here, which needs to be connected here as well. And then I've got what I believe will be my reset hold, and this is the same signal that comes off of the voltage supervisor that makes sure that my voltages don't fall too low. It's pretty strict about that too. What I didn't take into account was the fact that I still need to power this particular board. So I need to solder power in, and I'll probably take it from up here somewhere, just making sure that VCC is on top and ground is on the bottom. These are alternating VCC and ground all the way down. Over here, I've got another breadboard that I'm going to use, and for that I'm going to install some LEDs. Now I borrowed these from the ALU input off the other breadboards. I'll give those back here when I'm done. Each of these will then be able to be jumped down here, and then I need for inputs over here, I need 16 lines brought down so I can actually manage inputs into the Control ROM control at some point. For that, I also need power here, so I'm going to solder in another one of these connections over here so that I am able to take power from this point. The clock will take power from this point up here. Alright, I got a little bit of soldering I need to do. I want to knock that out first, and then I will get this all wired up and connect these. I've got to go find the schematic to figure out exactly what points these are, because frankly I don't recall. Okay, that handles power and ground. Now I'm going to hook up the common ground all the way across for the cathode of all of these LEDs. Now I do have current limiting resistors that were soldered onto the bottom side of this. And because this was a different pattern of holes than where I pulled it from, I'm just going to tie this one here at the end. So the next thing then is getting a bunch of little short hookup wires and connecting pin for pin down. Okay, next is all of the actual instruction inputs. I need to determine them positively whether there are VCC or ground. And I'm just going to go for an alternating pattern here just to save on space. Okay, now for these signals, the CPU clock is going to be on pin 15. The raw system clock is on pin 12. Reset hold is on pin 10. And reset itself is on pin 9. Now there are some grounds that flow in between those, and I am not going to worry about those at this point in time. Alright, I think we are about ready to apply power. Should I do a sanity check first? So continuity mode, it beeps, but it beeps very softly. Let's check two adjacent pins here. And I actually have a short somewhere along the line. So I need to go dig that out and figure out what's going on with that. Ground to ground, VCC to VCC. Where would said... It's likely going to be here. Let's pull that, find out if I still have a problem. I do. Let's pull that and see if I still have a problem. I do not. Yeah, I know I'm kind of doing everything but the obvious, but I really don't want to have to reset all of these jumper connections, but that's likely going to be what needs to happen. So I'm going to blame these, and I will reset those. Okay, yeah, that cleared it up. So let's start with pin. I guess the question then is, do I have a connection here between adjacent pins? Which is entirely possible as I look at this IC. Yep, I do. I've got a bridge connection here that I need to sort out. Now, how did I find that? I just happened to look at it and see it. Now I'm making an effort to put that alternating bit pattern back in place while I'm waiting for the soldering iron to heat up. Still bridged. But that bridge is gone. That's the problem. It's not a problem with the soldering, it's a problem with my hookup. And that is because the most significant bit here is intended to be always connected to ground. So let me get a better connection here. And I'm just going to drop that in here and pass that over here always to ground. I'm looking at this, I'm thinking I might be prepared to hook up power and give it a go. Alright, to apply power, I want to hook up VCC up here on top, ground down here on the bottom, and let's turn power on. Okay, I've at least got lights lit. I am over current at the moment, so let's turn that back off. Okay, I improved the allowed amps, and let's give that a shot. Alright, yeah, I had it limited to 148 milliamps, and it's drawing 155, so I'm good there. I'm not coming out of reset here, and so is this my reset hold signal that's holding that? No, it is a power problem. So rather than using these posts here, I've actually got to come straight to this board so that the voltage supervisor remains happy and that signal remains on or off, meaning that it's good. I need to go back now to my schematic. Alright, CPU clock was on pin 15. The raw system clock is on pin 12. This is counting, and that's a good thing. My reset hold is on pin 10, and reset is on pin 9. So if I reset, that should be counting, but I'm still in hold. Now, am I in hold for a voltage problem? I am not. Now, I am expecting this LED to be on. Okay, I spent about 20 minutes looking at this because I didn't realize that the least significant bit is on the left and the most significant bit is on the right. Once I get that figured out, it becomes very easy to get this particular issue sorted. This is my least significant, this is my most significant because of the way I've got this wired up. That LED being off is actually 100% accurate, so that's perfect. I reset, and it is counting, and I now can observe that it's actually counting in the right sequence. The only thing it's not doing is once it's done, it is not switching over to the address bus input, so I need to get to the bottom of that. Or maybe my expectations are not right. See, this goes out to the program ROM, so leaving it at the highest address it counts to is appropriate to do. But if I reset here, bit 0 looks like it's floating between high and low, and at the end it goes low, the bit next to it is high, the bit next to it is low. So I am actually correctly doing this. This is working as expected. This is actually a good test. Building out and installing the Control ROM control module and testing that to the point where I believe that I'm in a point where I can start adding the control ROMs themselves and testing those out. It's a pretty good milestone for today's video. I'm thrilled to where I've gotten to. I do want to address the fact that there was one issue that I just kind of glossed over and really didn't address, and that is the reset hold signal. Looking at it a little bit more closely, you can see that there is a jumper between reset and reset hold, effectively putting those two on the same node. And that's not going to work, obviously. So the reset hold, I really do need to build out a proper reset circuit and get that integrated in, but that at least explains where my issue was, and I can move forward with some confidence there. Do have to address it, but it's not urgent for today. The next video, I'm going to start with Control ROM 0. I'm going to install that and start getting some tests against that. That one is critical, in particular for incrementing the program counter. And so if things work well, I'll even drag out the program counter and see if I can't get that integrated in as well. We'll see how far we get in the next video. We'll see you soon.